Hello everyone, myself Swati. Today we are going to discuss about analog circuit. In that we have seen linear application of OP-AMP. Today, along with the previous lecture, that is a non-linear application of OP-AMP, by taking that base of this topic. Along with this, we have studied that comparator. Today in this lecture we are going to study that comparator application. Now let us see about that. First application of the comparator is window comparator. Then what is the meaning of that window comparator or comparator? Is a meaning comparator is used to compare in between input voltage and reference voltage. Along with this, whatever the output waveform is observed for that comparator, that shape related to that comparator is a window line. For that purpose, that comparator is called as a window comparator. A window comparator is basically the inverting and the non-inverting comparators above combined into a single comparator stage. A window comparator detects input voltage level that are within a specific band or window of voltages instead of indicating whether a voltage is greater or less than some present or fixed voltage reference point. That means window comparator is basically related to inverting as well as non-inverting comparator. Just see, here is the involvement of both these inputs. Along with this window comparator, just see, this time instead of having just one reference voltage value, a window comparator will have two reference voltages implemented by a pair of a voltage comparator, one which triggers an OP-AMP comparator on detection of same upper voltage threshold. That is, a V reference is related to upper threshold voltage, and one which triggers an OP-AMP comparator on the detection of lower voltage threshold level. That is, a V reference is in a lower state. Upper threshold voltage and lower threshold voltage. It is a combination related to two reference voltages for the window comparator. Then the voltage levels between these two uppers and lower reference voltages is called as window. Hence it is named. That means there is a difference in between these two uppers and lower reference voltages. For that purpose, that upper and lower voltage level difference will be gives us a window like shape. For that purpose, that comparator output is called as a window comparator. Then along with this, using our idea above of a voltage divider network, if we now use the three equal values resistor, so that just consider R1 is equal to R2 is equal to R3 is equal to R. We can create a very simple window comparator circuit as shown. Also, as the resistive value are equal, the voltage drops across each resistor will also be equal at 1/3 the supply voltage, that is a 1/3 VCC. So far as in this simple window comparator example, we can set the upper reference voltage to 2/3 VCC and lower reference voltage to 1/3 VCC. For that purpose, there is a basic difference in between upper threshold voltages and lower threshold voltages. Again, consider the window comparator circuit which is given below. This is the window comparator circuit. Just see, this window comparator circuit is formed by connecting two op-amps with each other by giving input voltage and reference voltage for first comparator, that is a 2/3 VCC, and for the second comparator, that is 1/3 VCC. For first comparator, input is applied to first and second. The input signal is applied to negative terminal of the op-amp, and reference voltage is connected to the positive terminal of the op-amp. Just see here, 2/3 VCC is connected for the first op-amp for the positive terminal, and 1/3 of VCC is connected to the negative terminal of the op-amp. That means Vin is the input voltage is connected for the first comparator, that is the inverting terminal op-amp, and for input is connected to the comparator op-amp 2 for the positive terminal, that is a non-inverting terminal of the op-amp, and output is which is introduced by that window comparator just we have observed here. Then VCC, that is a V reference, it is related to upper V reference, and for the V reference it is related to lower point, and the total cross sectional area will gives us, that is a window like step. This is related to window, this middle portion is related to saturation region. For this case the input voltage is greater than V reference voltage. For that purpose that curve or that edge is a for an rising edge. For a time being some time limit, that signal goes on to saturation region, that is a steady station, and for Vin is a less than V reference, then it will be goes on down like this. V reference for the upper threshold and V reference for the lower threshold. Here that waveforms are shown. That waveform is for the window like structure. For that purpose this type of a comparator is called as a window comparator circuit, and which is having input reference voltage, that is a 2/3 VCC and 1/3 of VCC. Then along with that window comparator circuit continuation, the initial switching condition of the circuit is the open collector output of the op-amp, that is A1. A1 is the gain related to op-amp number 1, which is off, with the open collector output of the op-amp 2. Then op-amp 2 for the gain is A2 on, that is a shrinking current, that is a for the op-amp 2 it is a on, that is a shrinking current, and for the op-amp number 1 it is an off condition. So the output is equal to 0. For that purpose one op-amp is on and another is off. For that gain difference or gain whichever introduced related to that output voltage from throughout the circuit, that is op-amp number 1 and op-amp number 2. From op-amp number 1 and op-amp number 2, that Vout is equal to 0. When input is below the lower voltage level, that is a lower voltage level, that means lower voltage level is related to 1/3 of VCC. Then input voltage is below 1/3 of VCC. Then what happened? Which equals to 1/3 of VCC, Vout will be low. When Vin is exceeds this 1/3 of VCC, that is when Vin is greater than 1/3 of VCC, then lower voltage level. Thus the first op-amp comparator detects this and switches its open collector output high. This means that both op-amps have their outputs high at the same time. That means both the op-amp is having outputs at the very high level stages. That means it does not go on any lower level condition. Their threshold value is related to cutout region, that is a 1/3 of VCC. No current flow through the pull-up resistor RL, so Vout is equal to VCC. That means there is no any kind of a pull-up resistor is introduced from this circuit. For that purpose output voltage is equal to positive VCC. Along with this window comparator, what that window comparator circuit says is that as Vin continues to increase, it passes the upper voltage level, that is a V reference related to upper voltage level. What about the upper voltage level, threshold voltage level? This is a 2/3 of VCC. At this point the second op-amp comparator detects this and switches its output low, and Vout becomes equal to 0 volt. Then the difference between V reference upper and V reference lower, which is 2/3 of VCC minus 1/3 of VCC, is the example that will create the switching window for the positive going signal. That means the window will be switched out by taking the difference 2/3 VCC minus 1/3 of VCC. What it came into picture, that is a 2/2 VCC. That means what is the output came into picture here as a VCC output. Let now assume that Vin is at its maximum value and equal to VCC. That means input voltage is directly proportional, or it is exactly equal to, that is a collector voltage. As Vin decreases, it passes through the upper voltage level, that is a V reference upper. V reference upper, it is we have taken, that is a 2/3 VCC. Just here I have mentioned of the second op-amp comparator, which switches the output high. As V continues to decrease, it passes the lower voltage level, that is a V reference lower. What that V reference lower we have considered, that V reference lower we have considered, that is a 1/3 of VCC of the first op-amp comparator, once again switching the output low. Along with this, then the difference between V reference, that is a upper reference voltage, and V reference, that is a lower reference voltage, creates the window for the negative going signal. So we can see that as V passes above or passes below the upper and lower reference levels set by the two op-amp comparators, the output signal V out will be high or low. That means it will be passes either in a upper direction or either in a lower direction. It does not matter that is the input or reference voltage is at a high or low level. In this simple example, we have set the upper trip level at 2/3 VCC and the lower trip level at 1/3 VCC, because we used 3 equal values resistor. That is we have seen, that is R1 is equal to R2 is equal to R3 is equal to R. For that purpose, here we have considered that upper trip level it is a 2/3 VCC and lower trip level it is a 1/3 VCC. But we can be any value we chosen by adjusting the input threshold. As a result, the window width can be customized for a given application. Along with this, if we use a dual power supply and set the upper and lower trips levels to say plus or minus 10 volt and V was a sinusoidal waveform, then we could use this window comparator circuit as a zero crossing detector. That means it will be crosses or it will be seems like a zero like structure, zebra like structure. For that purpose, it is called as a zero crossing detector of the sine wave, which would be produces as a output. This output which is produced by that zero crossing detector is either having a high or a low every time the sine wave crosses the 0 volts line from the positive to negative or negative to positive. We can take this idea of detecting the voltage levels further by connecting a number of different op-amp comparators together with them, all using a common input signal, but with each comparator using a different reference voltages set by our now familiar voltage divider network across the supply. Consider the voltage level detector circuit below. For that purpose, we have designed that voltage level circuit, and that circuit is given below. You see here, this is a comparator voltage level detector circuit. For that comparison purpose, here 4 op-amps are connected parallelly, that is op-amp number 1, 2, 3, 4. Along with this, for every non-inverting terminal of the op-amp is related to input supply. That is just see here, this is for op-amp number 1, this is op-amp number 2, this is op-amp number 3, and this is related to op-amp number 4. This input is connected along with that variable resistor, and reference voltages for every op-amp is connected to inverting terminal of the op-amp. That is a V reference 1. Just see here, it is connected to inverting terminal of the op-amp. Then V reference 2 is connected to the inverting terminal of op-amp 2. V reference 3 is connected to the inverting terminal of the op-amp 3. Then V reference 4 is connected to the inverting terminal of op-amp number 4. Along with this, we have clubbed all these inputs, and that inputs are connected towards that ground, and one more LEDs are connected across the output of each and every comparator. This is LED number 1 is connected across the output of comparator 1, that is op-amp number 1. LED 2 is connected related to op-amp number 2. LED 3 is connected to op-amp number 3, and LED 4 number is connected across that op-amp number 4. LED or a photodiode, we call it as a LED or photodiode, and this will be displays the comparator voltage level detector. That means it will be displays comparator voltage levels. Along with this, as above, the voltage divider network provides a set of reference voltages for the individual op-amp comparator circuits. To produce the 4 reference voltages will require 5 resistors. The junction at the bottom pair of resistors will produce a reference voltage that is 1/5 the supply voltage. 1/5 VCC using equal value resistors. The second pair, that is a 2/5 VCC, and third pair is a 3/5 VCC, and fourth is a 4/5, and fifth is a fifth amount of the 1/5 is a 1/5 towards that fifth, that is a 5/5 VCC. Similarly, suppose first stage is considered as a 1/5 VCC, for second 2/5 VCC, for third 3/5 VCC, for fourth 4/5 VCC, and for the fifth 5/5 VCC, which is actually exactly 5/5 VCC is exactly equal to VCC. By calculation we can easily understood how that VCC is came. That is a 5/5 gets cancelled, and what is the remaining? Here remaining is a VCC. For that 5/5 step, that output voltage is only came into picture, that is a VCC. Along with this, as the common input voltage increases, the output of each op-amp comparator circuit switches in turn, thereby turning off the connected LED starting with the lower comparator A4 and upwards towards A1 as the input voltage increases. So, by setting the values of the resistors in the voltage divider network, the comparators can be configured to detect any voltage level. One good example of use of that voltage level detection and the indication would be for a battery condition monitoring by reversing the LED and connecting them to 0 volt. That is, it is connected towards a ground instead of VCC. That means whatever the input is applied to this circuit, we are directly connecting that input towards that ground. It is not connected towards VCC. Along with this comparator, also by increasing the number of op-amp comparators in a set, more triggering points can be created. Like this I have told, that is a 1/5 VCC, 2/5 VCC. Like this 5/5 VCC is a finally comes towards that VCC. Like this we can divide number of stages or number of triggering levels. Also by increasing the number of op-amp comparators in the set, more the triggering points can be created. So for example, if we had 8 op-amp comparators in the chain and feed the output of each comparator to an 8 to 3 line digital encoder, we could make a very simple analogy to digital converter ADC that would convert the analogy input signal into a 3-bit binary code, that is a 0 to 7. That means it is a 8-bit binary code. Then op-amp comparator with positive feedback. That means op-amp comparator, just we have discussed that is a op-amp comparator is having either positive feedback or it does not having any kind of a feedback. Apart from that, first we are going to take example related to op-amp comparator with positive feedback. Just see, we have seen here that operational amplifier can be configured to operate as a comparator. Just we know in their open loop mode, and this is fine if the input signal varies rapidly or is not too noisy. However, if the input signal, that is a Vin, is slow to change or electrical noise is present, then the op-amp comparator may oscillate, switching its output back and forth between the two saturation stages, that is a plus VCC and minus VE, as the input signal hovers around the reference voltage. V reference level, one way to overcome this problem and to avoid the op-amp from oscillating is to provide positive feedback around the comparator. Along with that, op-amp comparator with positive feedback, just see here, as its name implies, positive feedback is a technique for feeding back a part or fraction of the output signal that is in phase to the non-inverting input of the op-amp via a potential divider set up by two resistors with the amount of feedback being proportional to their ratio. And this is all about that OP-AMP comparator. I hope all things are cleared related to window detector. And this is today's example related to that comparator. One more example we are going to see in our next lecture related to comparator. Okay, thank you.